Integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast, powered by EXO, hosted by Zachary Oliphant.
Well, Ken, welcome to the Integrity Podcast. Excited to have you here today. Let me give, for all you guys watching and listening, a little bit of background on Ken so I can make sure I get this right, because he, like a lot of our folks, has lots of acronyms after his name, so I want to make sure we get these correct. So Ken graduated with an architectural engineering degree from the University of Texas and from Harvard Business School's General Management program. He's a professional engineer licensed in the state of Texas. Ken has a combined 24 years of technical and leadership positions in structure manufacturing and another 10 years in consulting and utility engineering. He's a fellow of ASCE, American Society of Civil Engineers, and a fellow of SEI, which is the Structural Engineering Institute. Ken is actively involved in several industry codes and standard committees, including leadership and executive roles. Ken has authored and presented numerous papers and articles in the design, manufacturing, and application of critical infrastructure assets. And he has a track record of innovative solutions to achieve quality, economic, and aesthetic results, including multiple materials and multiple U.S. design patents. And currently, Ken is EXO's Vice President of Utility Services, located here in Houston, Texas. So, Ken, thanks for joining me today.
Thanks for having me, Zachary.
I think the conversation is going to be awesome. Look forward to all of your experience and getting to share some of that with the broader audience. So maybe we start with, how did you get into engineering? I think it's always an interesting question on what guided you into becoming an engineer to begin with.
Well, where I'm from in Southeast Texas, most of the kids were destined to work in refineries or go pursue a chemical engineering degree, which is not bad work. But my particular passion was in seeing structures, seeing the physical outcome of the things that I built. And that really all started in my grandfather's garage workshop. And then it just got magnified in my seventh grade industrial arts class.
Oh, fun.
I built a gun rack out of cherry with a coping saw. And I was hooked at that point to use materials and tools to build things. So that led me, when it came time to choose college or career, I learned about architectural engineering, which is a civil structural engineering program that a lot of CE programs have. And that just seemed to be right in my wheelhouse. And I was pursued that, and then ultimately, while I was in school there at UT in Austin, I got a part-time job as a relay drafter. Whatever relay engineering was, I had never heard of it, but there was a friend from church who was an electrical engineer, an older gentleman, and he helped get me a job in the drafting room. So I was drafting what are called relay drawings, which is lines and dots dashed in hollow, and I had no idea what I was looking at. And a couple of the drafters, Ray and Nora, came over and asked me if I was a double E major. I said no, CE, civil engineering. And they immediately said, you need to go meet the guys in the transmission engineering
You're in the
group.
wrong department, kid.
You're in the wrong department.
We're going to move you over.
We need to introduce you to the transmission engineering group, which also was meaningless to me because I had no idea what transmissions had to do with an electric utility. But I soon discovered the wonderful world of overhead power lines and pursued a career in there right out of school.
Okay, so you get out of school and then you start working for the local municipal utility there in Austin?
Exactly.
Okay.
My first day, as a matter of fact, was a paid holiday. And I thought, hey, this degreed engineering gig was pretty good. But no, seriously, the types of projects I was able to do as a transmission line designer were really gratifying. I was learning from the older engineers what design requirements were really governed what we did as a line design and structure analyzing group at the city of Austin.
Yeah, and I was going to ask you, because we see this a lot with our folks, is there's usually a couple people early in their career that really helped guide them or mentor them, especially in these highly technical degrees where there's a lot of tribal knowledge that's handed down generation to generation. Was there anyone particular at Austin Energy, I guess now Austin Energy, that was that for you as a young civil engineer?
Yes, and now it is cool enough to call Austin Energy as opposed to the electric utility department. But yeah, there was really a group of folks, and the head of our section was Jeff Suggs, who was actually a double E, ironically. But we had civil engineers that invested in me, but Jeff was our leader, and I was intrigued with his leadership style. He allowed us to do our jobs, and he created a culture where we could enjoy working as a team. And so I would really count Jeff as the mentor during that stage of my career. Absolutely.
Well, good deal. So you stay at Austin Energy for a period, and then what happens next?
Okay, so my degree's in architectural engineering, and what am I doing working for an electric utility? Nobody was more surprised than me that I would discover a career at an electric utility as a civil structural. But like I said, I quickly grew to appreciate the projects that I was involved in, but then an opportunity came knocking. And I had an opportunity to go to work for a consulting engineering firm specializing in high-rise buildings. And what good architectural engineer won't jump at that opportunity? And it was an amazing time, but after a few years, I had the opportunity to either return to the electric utility or in the industry there, or continue in the building design industry with another firm. And I chose to go back to work for the utility. And it's really interesting, Zach, at that point in time, when you've been in the outside world and you return to working for the utility in this case, you've tasted the outside world and you have some additional credibility, deserved or not. But at that point in time, some really interesting and challenging projects started being directed my way, and they were very challenging, like I said, and those opportunities really enhanced my leadership because it was a project, not necessarily just a structural design. And those projects involved other elements of leadership and other elements of responsibility to coordinate all the necessary teams and timelines and budgets that make a successful project.
So Ken, a lot of people think, you run in your house and you flip the light switch on, power comes on, that it just should always work, and it's not very complicated. You lived not only in a utility, but outside selling materials to support a utility. Maybe walk me through a little bit of just the sheer complexity of the utility grid.
So the grid, which is in the news more and more these days as you see an emphasis on resiliency and reliability, doesn't just happen at your light switch. Yeah. It is, you trace that on back through, you've traveled through miles of circuits, whether they be starting from the generation plant or passing through the conversion station into the transmission lines, the high voltage lines that move across country and long distances, and then in the substations where transformers and very odd looking structures hum and spark and then come through your neighborhood on distribution lines, either overhead or underground. There's a lot of planning. There's a lot of materials. There's a lot of engineering design that go into the power distribution system. My brother used to tease me as being a telephone pole engineer because he didn't see how one structure could be any different than another.
Yeah, and they're all so very different. And once you get in the business, you obviously understand that. So you spend this time working for a utility, and then you decide to move out into the commercial space. Kind of walk me through that experience for you.
Right. Well, I had an opportunity, and at this point in time, they at the utility they threw a Bon Voyage 2, starring I'll Be Back Ken Sharpless. But I went to work for a manufacturer that supplied structures to the utilities and designed them. And so I was very intrigued getting back to the woodworking and the industrial arts class, then the materials and the tools, like I did with the wood, the cherry wood and the coping saw, is here's a manufacturer, and there's all sorts of disciplines there, all sorts of different pressures to produce the designs and the drawings according to what was sold and needed for the line design requirements. And you're in a team that has professionals, whether they be certified welding inspectors or non-destructive testing technicians or welders that are performing and really carrying out the drawings and specifications are really the will of the engineer that structurally designed this component that goes into an overall structure that satisfies its job in the overhead power line structure. And so that whole team and that whole process was really intriguing to me. So I was able to join what at the time was a small manufacturing company, which then later was an acquisition by a company called Newmark, where I was able to go to work for somebody I already knew already, but it was my first time to work for Wes Oliphant and learn, number one, learn that Wes was going to have me be what was called the general manager of the now 5th plant of Newmark. And I quickly was aware of new responsibilities, new pressures to lead a team, to be responsible for a business that had metrics, that had goals, that had a profit and loss budget. And we had everything. As a general manager, we had sales, we had HR, we had procurement, we had production, we had quality, and we had customer service. And all that responsibility, the other GMs at Newmark quickly came alongside of me and said, you're going to feel that responsibility in your gut. And it is true.
It's an interesting pressure when you have P&L responsibility or general management responsibility or you're a leader of a business. The pressure of all the people that work for you and all their families and their paycheck every day, that's a unique pressure that takes some learning on the job to get used to. And I've always seen in my career, Ken, the more that everyone in the organization can feel that pressure, the pressure that a GM or business unit manager is feeling, the stronger you make an organization,
Absolutely.
Right? If the drafter feels it and the welder feels it, and everyone has that same buy-in that my job is making everyone else's job really valuable and important to them, it really makes a business successful.
Absolutely.
So you're in the manufacturing world for a while. Obviously, you've got several patents that you are involved in, several really unique technical solutions. And then you made this other kind of shift in your career to someone like Exo, more of an professional services business. So you go from manufacturing now to the other side of the fence, which is quality assurance work and all of that. You hit a little bit on reliability and resiliency. So now as you look at our business and the clients we're servicing, and we think about reliability and resiliency of an aging infrastructure, maybe walk me through a couple examples of some projects or clients that we've supported and maybe what we've done there.
Sure. It is, the way I like to think of it is that we design and manufacture the infrastructure that supports the advancement of society, which is our grid, which is the electric distribution system, supply and distribution system. And the pressures that manufacturers go through to design and manufacture and deliver structures for a power line comes really at the end of a long process that the utility has been involved with. They've nurtured this need. It started out as a circuit, much like a relay, where there was 2 points that for reliability and resilience of the grid needed to be connected with a certain voltage. And that then becomes a long road of defining routes, determining environmental impact, getting public participation, doing designs and preliminary designs, ultimately headed for a budget and for a permitting authority from the Public Utility Commission and rate and potential rate rate cases to justify that infrastructure. So this project that comes to the manufacturing and construction stage has been squeezed. That schedule has been squeezed, and there's been a lot of pressure. So I empathize. I've been there in the manufacturing role, in the line design role, where I respected the process that brought this project to the point where you can apply funds to it. You can apply orders to it. And respecting the project and those that advanced it that far down the field is an important part of how I think ultimately this relates to what EXO does. Because that set of pressures oftentimes produces strains on resources, it produces strains on knowledge and in work hours. There's all sorts of opportunity for those pressures to translate into maybe a quality escape. And one of those things that we do at EXO not only is doing a vendor quality audit and a scored audit about their ability to be set up for performing that important role, but also some in-plant inspection during our utility clients' project as it passes through that process that we've already audited. And it's very important that those, for the success of everyone, including the manufacturer, including the contractor, and especially, obviously, the utility, that quality issues are identified and dealt with at that point in time.
That's right.
Because if they escape the manufacturing plant or the galvanizing yard, then it's only going to be a more expensive option to remedy, and a lot fewer options to do, especially even if it gets installed and that problem starts surfacing maybe at the end of the warranty or later in life.
That's right. Yeah, and it's really interesting. We get some feedback sometimes for clients of, well, I selected a good manufacturer, and you probably did. I mean, with in the way you're measuring that, which is usually price or lead time or capacity. But what a lot of folks aren't understanding is under all of that extreme pressure where we've got to get it designed and get it manufactured very quickly, and you shove all of that pressure through the system, the thing that usually gives is quality. And when production is being pushed, quality is always kind of that last piece that is always somewhat at odds with production throughput. And quite often we see those kind of quality escapes that have a real dramatic impact on a particular project. So as you think about our service in a factory, and we think about it as kind of trust and verify, right? Trust you selected a good manufacturer, great. But you need to verify you're getting good quality work. And I think of it, like your favorite restaurant you go to, right? That's you've loved for years and years and years, and all of a sudden the manager changes, or your favorite waiter or waitress changes, and all of a sudden the service seems to drop.
Exactly.
That happens in manufacturing environments too, where you've got great inspectors or great welders or great shop floor leadership that retire or go take on another job, and all of a sudden the quality can dip. And so that trust but verify piece we find is really important in that aspect of our business, certainly. So as we continue, so that's kind of reliability and resiliency and hardening of the system with new materials,
Right.
auditing and in-plant inspection. You have an example on aging infrastructure. I know you spend a lot of time in some of the committees that you're on thinking about aging infrastructure and maybe how utilities are thinking about their infrastructure that's aging.
Let me talk about, in answering your question about aging infrastructure and what we see. Essentially, I'll start with this. I'm a runner. I like to do distance events, and I like to pack my shoes wherever I go and find a new trail to run along. And I often find that I'm running past a transmission line because they make nice linear trails. And I will have my phone with me, and I will often have to stop and pause my Garmin Strava watch and start doing a little structural inspection because I see corrosion, whether it be on direct embedded poles or lattice tower legs or even anchor-based structures. It's out there. Today, it's continuing its next day of corrosion. It has certain systems that were originally designed to protect it from the environment, but those systems are designed to sacrifice themselves until one day that is no longer there to protect the base metal. For example, we had a project last year at EXO that was up in the Ohio area, and there was a line that was originally put in out in some open fields, no residential or commercial streets in the area. And this line was weathering steel, which was back in the 1970s sort of introduced as a maintenance-free.
Maintenance-free. Yeah.
But that's a 50-year-old structure now. And interestingly enough, on that line, there are now homes built right up where their backyard fence is on goes right up to and through around each pole structure. So the access to these poles is pretty limited. They're being fertilized in flower beds and all sorts of things in people's backyards. But a portion of it's also along a trail. Like I mentioned, I'm a runner. There's people hiking and walking dogs along this trail, and a person from the public noticed a hole in the side of the pole. And
usually not a good thing.
Not a good thing. And they reported that, and then one thing led to another. A number of folks, different consultants arrived and had different theories on what caused the hole to be there. But in our case, when we came into the picture, we were able to assess the wall section loss, the impact on the overall cross-sectional strength of that pole, and more importantly, know how to remedy that. Mm-hmm. We actually had various degrees of remediation options depending upon how severe the corrosion was. So we were able to go in there. One of the things that the utility was facing was a problem. The public didn't want them there. The neighborhood didn't want them to change out the pole.
Tear up somebody's backyard or what have you.
Exactly. And that was going to involve a lot of equipment, and it was going to involve a lot of damage to their backyard, as you say. So one of we adapted a solution that we'd used in some other parts, some other utilities, and it was really a splint or a load transfer bracket that we came up with. First, we would take care of the corrosion and the coatings in that area, but rather than custom design a specific welded plate and all the equipment that it takes to do that, we were able to manufacture elements that would bolt together in an arrangement that we could hand dig the hole and that we could arrest the corrosion action and then assemble around that pole very aesthetically a bypass of that part of the pole that was structurally compromised, restoring its strength and extending its life for hopefully another 50 years.
So you walked me through this very interesting story related to corrosion. Maybe give me an example on the kind of reactionary type of work we do sometimes. We get all kinds of interesting phone calls from clients. Maybe give me one of those examples.
Absolutely. The one I just worked on is in West Texas. It was a 138 kV line that was not very old, just a couple years old, and we had a West Texas thunderstorm, which was pretty significant, but nothing close to what the line was designed for. Mm-hmm. And they had a mile of line cascade fail. What that means is there was 13, 14 structures laying down on the ground.
And they kind of go one after another in sequence as they're failing.
That's what we needed to determine. Mm-hmm. They called EXO. Houston, we have a problem. And we have the reputation when something catastrophic happens on a high voltage line or distribution line for that matter, people know that EXO has the engineering expertise and the manufacturing background to be able to mobilize and investigate, do some forensic work, do some lab metallurgical work if that's what it takes, and the engineering and manufacturing backgrounds in-house to be able to get to a root cause of that failure. And oftentimes, that leads to new provisions being proposed for our codes and standards. And at the very least, something that the utility can incorporate into their own specifications, because there are details that matter that a minimum design code standard won't address, that you as a utility will want to have in your specification.
Absolutely.
So in this case, they needed to know, why did a mile of line wind up on the ground of a 2-year-old line under an average Texas thunderstorm? So we went out there and started trying to investigate what triggered this. Was it the entire line going across like a fence that just got a straight line wind for a mile wide, and did it fall down all at the same time? Or was there something else going on? And it's not untypical to have a trigger event and then a propagating or a cascading failure of the neighboring structures, like dominoes, once one structure has failed and there's no provisions to cease or arrest that failure through the design of the adjacent structures. And that's what happened in this case. We investigated and found out that, interestingly enough, it wasn't just a ground line cross-sectional overstress. There was something up the pole where there was an overlapping slip joint, and there was some peculiarities about the design and the manufacture of that slip joint that we were able to determine that, yes, indeed, that's where the failure initiated. And then we went through other line models to determine what stresses then impacted the adjacent structures, to the point where it failed and cascaded to a point where then it hit a dead-end structure.
Yeah, and I think you hit on some real key elements there, Ken, that makes EXO pretty unique, right? It's all of this engineering and technical experience and background. We've had several of those folks on the podcast here, including yourself with all the engineering background. That's critical in this root cause analysis. But then you have this inspection component. Okay, the pole's on the ground. You know what to do with that pole. But what about the poles that are several poles beyond that? What kind of damage maybe did they see? So all of the technical expertise to go and look at those poles that are still standing, but maybe deficient in some way due to some stress. And then what do you do about it, right? It's the third piece is, now how do I go in and rectify, remediate the situation? And there's very few folks out there that can do all of that engineering and analysis, the in-field inspection, and then synthesizing all that into a remediation that ultimately is trying to give the client the best solution.
Absolutely. And that's the thing that resonates with us as a team at EXO. And what I love about working and being a part of that is to have problems, but to have the team to be able to mobilize the whole of our experience in a solution that solution is not any cost. It's with it in mind that there are replacement solutions, but if we can extend the life or restore the strength of a structure, certainly catastrophic failures are one thing, and then slower attacks on the structural integrity of a structure or a series of structures is another thing. But our solutions brain trust can come to those projects wherever they are, because at EXO we've got a fleet of vehicles and tools, and most importantly, the field inspectors, the training that they've received, the credentials that they have, and the knowledge that they bring. The utilities don't have that luxury anymore. Back when I started at the utility in Austin, we had a very strong engineering department. We had our own construction crews, and we had knowledge that we could bring solutions internally, but that's very rare these days. So EXO fills this spot in the industry where we have people that have worked for the utilities, that have lived those problems and been in manufacturing and have seen where those problems maybe can start from and the pressures that cause that, even in the construction side. So it's a team effort, but to be able to deploy the field personnel and have the team at the headquarters huddling to do the appropriate decision asset by asset allows us to provide a solution no one else can.
Absolutely. And you think about issues in the industry. One of the ones that we find that's pretty interesting, so we've kind of hit a little bit on the distribution side. Now you talked a little bit about the transmission side, really related to substations and substation structures. And as you mentioned earlier, I mean, substations have some of the highest dollar equipment that a utility owns within a substation. If anyone doesn't know, a substation, you see the transmission lines come in and come out, and usually the voltages are getting stepped up or stepped down depending on where they're going. And within a substation, they're usually all built with big walls or fences and barbed wire and all sorts of stuff because they want to keep people out. One, for safety reasons, and two, you've got multi-million-dollar transformers and tons of switching equipment, very expensive assets or sites for utility. Maybe walk me through an example there on the substation side, some of the things we're seeing in the industry, and maybe some solutions we could provide to clients.
Sure. Yes, those walls and those confusing lines entering and exiting these unlike a transmission line, which spans for miles and miles and traverses through neighborhoods and suburbs and countryside, that's a long, continuous infrastructure project. But a substation occupies a site. Mm-hmm. So now you're more like a building. But to your point, there's usually a wall surrounding that, and it's like, well, don't pay attention to the man behind the curtain. There's a lot going on there. You mentioned the price of the equipment. It's also the lead time of that equipment. Mm-hmm. Most of the time, those transformers and those complicated switching apparatus are sourced overseas. Mm-hmm. And so there's a supply chain that affects the ability to recover if you were to have damage to any of those assets.
That's right. Some of those run 6, 8, 9, 12-month lead time to replace.
Absolutely. And so with that in mind, when we have a call, either for a program to go inspect substation structures, whether it be the stands or the dead-end structures, the big A-frames, or even the structures that are designed to protect that equipment from lightning strikes, the shield wire support structures or the static mast structures, those are there to protect that substation equipment from lightning strike. Makes sense. It's interesting, one of the projects that we got involved with last year was the failure of one of those static mast structures that just timber from the base of that structure, it fell flat on its face. So there's a structure intended to protect that substation that now has become a danger to that substation. That could have easily fallen a few degrees right or left and been on top of that very expensive transformer or switchgear. And so why did a structure that's in the substation fail? And so we got involved in looking at the root cause of that. Oftentimes, those structures are subject to that wind-induced vibration or vortex-induced vibration. Unlike many of the other structures on the power lines that connect substations, these individually standing structures aren't dampened by the lines themselves. They are up there, they're tall, they're typically subjected to a lot of exposure area for winds to pass across them. And many of them have been designed from the beginning for a damper of some kind, whether it be an internal damper or strakes that spoil the air that flows around them. And they oftentimes, even though they should be, oftentimes they aren't protected by those systems, and they aren't designed for fatigue type loading. And that was the case that we found, is this structure was plenty large enough to take care of the load, plenty tall enough to support the shield wire well above the expensive substation equipment, but it failed because it wasn't being inspected. It wasn't suspected to be a threat to the rest of the substation. But that happened with something that's not unfamiliar. There was a dynamic going on at the base of that shield wire structure that's not uncommon to transmission structures, or for that matter, the dead-end structures and other types of structures within substations. But it was allowed to go unnoticed and unaddressed and uninspected to the point that it failed. And we've seen multiple situations like that. You're not going to fix that failed structure laying on the ground, but you want to understand why it happened and what you need to do with the rest of the structures that are in that same substation, and for that matter, in any substation.
That's right. And I think maybe you can speak a little bit to, Ken, this view in the utility space, and we do a lot of wood pole inspection work as well. Almost everyone inspects their distribution system on the wood pole side, and a lot of that is aging infrastructure as well, and you have rot and decay. But a lot of folks in their minds think of the non-wood products that they last forever. Oh, look at this big steel pole. Look at this big concrete foundation. Look at these anchor bolts. They're just going to last forever. What we find is that's not true. I mean, those structures, they degrade on a different timeline maybe than a wood structure does, especially a wood structure in the southeast where you have a lot of rot and decay. But they still degrade. And what we're finding is utilities now are being awakened to this new component of kind of O&M that they need to be thinking about, as a lot of that non-wood infrastructure is now becoming 40, 50, 60 years old, and they've really never looked at it in any detail. Maybe they do a patrol inspection, or like you said, a running inspection. You see the hole in the pole. That's those things they will pick up. But it's all of these other small defects that could be easily and cost effectively addressed early if they're caught early, that oftentimes just go too far and then become very, very expensive failures later.
Well, it's true. And you've seen it in the news, whether it's fires that may be traced back to hardware or hardware connection that is worn, or highway crossing structures that have not necessarily aging infrastructure, but relatively new structures that have been in service for 10 or so years that have some sort of latent defect that is now propagating to the point where it'll drop a conductor. And those inspections and the attention that utilities are able to put on those, there's a lot of work recently with resiliency and storm hardening. And storm hardening is very difficult to pay for, but it's obviously very tangible to the public and to the permitting entities to help utilities look at their assets and their lines with their eyes wide open, sometimes for the first time in many decades. And give them an avenue to be able to maybe capitalize some of the investment that needs to be made in the existing infrastructure. And that's encouraging to see. So I brought up a couple of different things. One is aging infrastructure, hardening, end of warranty inspection is something that utilities should look at, because many of the failure investigations and situations we get called out on aren't necessarily 30, 40, 50 years old. Right. They're 3, 4, 5 years old.
Yep. And, we both come from a structure manufacturing background, and, we as manufacturers always did a great job of keeping warranties relatively small. I think the industry standard is still a year or two on material that should last 40 or 50 or 60 years. Exactly. And that's a long time for that utility that's going to be maintaining and owning that asset. And certainly thinking about an end of warranty inspection, the utility is much better off knowing they've got a problem while they still have a warranty than a month or 2 years later. And it's only in year 4, year 5 of owning that asset. Well, now you've got to deal with this thing that, this asset that you should maintain for the next 40 or 50 years. That's an expensive proposition. And we've been involved on both sides of that coin, helping utilities find a problem before warranty expires and saving utility hundreds of millions of dollars, versus the opposite, where they engage us because they see some problem 5 or 6 years into owning an asset, and now they're spending tens of millions of dollars to resolve the issue themselves. That's not a fun situation for a utility to be in, especially when with really low cost dollars of really targeted inspections, you can know what you have. And, you can go to bed at night as a utility owner knowing that you've looked at these assets and they're in a good condition. And I think that's a lot of the message we're trying to get out there. An ounce of prevention goes a really long way to saving you pounds and pounds and pounds of headaches later on.
And we know that because we get called all across the country to investigate or to inspect these assets. We know what can happen. And as I mentioned earlier, there's really an absence of resident knowledge many times.
That's right.
And we have sort of the unique opportunity, but we also have a unique responsibility at EXO since we get involved in so many different types of systems and structures and designs and parts of the country. Our knowledge base just continues to grow, and our ability to address those problems for any utility is readily offered, of course, but we know what can go wrong. And one of the ways that we try to spread that knowledge is just offering a webinar about lessons learned the hard way. Mm-hmm. As a young engineer, when I was able to attend my first structure test and to see a structure intentionally loaded beyond its ability to resist and to fail catastrophically, I was mesmerized. The potential learning that comes from the behavior of the materials and the path of the load that goes on when you're able to see a failure is a unique opportunity to learn.
Absolutely.
Quote Wes Oliphant on that. It's why you test them.
Yep.
And so when we're able to do this webinar for engineers that need PDHs or just for the benefit and knowledge base of these groups of young engineers at utilities, it's a rare opportunity that we share to be able to look at a series of case studies that go through multiple examples of different types of failures that we've been involved in investigating, and then share the details that mattered. It's always well received. Issue out certificates of professional development.
Well, and I think as you're mentioning, Ken, one of the real challenges today, and we understand it from a legality perspective, utilities don't, obviously they don't like sharing failures that they have on their system. They got enough other challenges.
We'll do that for them.
Yeah. So certainly, they don't like talking about it, even with their peers, even with other utilities. They everything's locked down in NDA. I mean, us included. But we can talk in general knowledge base, as you're saying, of here are the things we're seeing, folks, that are leading to these problems. And sadly, we see it kind of utility after utility after utility. They all have the same problem. None of them are talking to one another. And we're kind of the center, the hub of this wheel where we've got all this unique knowledge from all of these challenging projects that we can synthesize, and it allows us to solve a problem much more expeditiously for a utility at much lower cost because we've been there and we've done that.
Been there and done that regardless of the material.
That's right.
Concrete poles, steel tubular poles, steel lattice towers, composite structures. These substation, distribution, transmission, we don't care. We're agnostic when it comes to that point. We've seen issues that can compromise any of those, and we offer that with what we do.
I always get a kick out of hearing calls from clients or requests from clients where they say, we think we've got this unique problem. We've never seen it before. We're like, no, we could show you. We can't show you, but we've got this long list of the exact same problem that lots of other clients have. It's just unique to you as a utility because it's the first time you've seen the problem, but we've seen it dozens or hundreds of times. And whether it's related to, like you said, a manufacturing issue, a design issue, aging infrastructure, corrosion issue.
And all the solutions that go with that.
Correct. Yeah, and
remediate.
then coming up with what is the right amount of application of the engineering bucket that we can bring, the in-field inspection bucket, and the remediation bucket. Those all have to really be balanced in the right amount to give the client the best, most economical solution that's going to help them predict and maintain their assets for a long time.
Well said.
And ultimately, that's the goal. Right? That's the goal for EXO. It's how do we use all of those different inputs to come up with the best solution? And I think that's the real value our clients see in the type of work we can do. So, Ken, you mentioned all of this great inspection work we do in the field. And one of the things I always think about, and I think our clients think about, is how do you synthesize all of this engineering data, inspection data, remediation data in a way, or simplify it in a way that makes sense for a utility to digest?
It's a great question. I think it is a challenge because done right, there's a lot of data to manage and to interpret. And so what we've done at EXO is we've created a scoring system, like we do audits on a scale of 100. We do A, B, C, D, and F, and these are very they're relatable grading systems, but that resides in a portal that we, as we inspect, whether we're inspecting with an aerial drone or a man that's inspecting an inspector that's doing NDT aerially, we will take that data and those images, and we will review and annotate those images and assign a score of the health condition of that structure. And you can imagine you have hundreds and thousands of structures, but a straightforward grading system on an A through F scale is relatable and it's actionable because you can set up time periods on what needs to be replaced, what can be remediated, stabilized, and extended. How can you bring it back up to an A if possible? That approach has been very helpful for our clients to see that there is data that's being gathered. It's being filtered through an engineering knowledge that we have at EXO and documented not only with the place for that data to live, but the score that that asset received. With that, there's all sorts of analytics and all sorts of programs you can run to manage and appropriately apply the funds that it would take to extend the life of not just that individual asset, but the line, the circuit that structure is in and all of its neighboring structures.
I think that's right, Ken. As you think about all this data we collect, we have to be able to have a story with our clients at multiple levels. At a C-suite level, they want to know the health of their overall system. At an individual regional manager, tell me about this particular transmission line. And for the guys in the field, whether it's us or it's a line crew, they've got to send out. I got to know all the way down to the singular bolt that's the problem. To be able to look at that from a very macro level and then dive all the way down into the micro is critically important. And then, like you said, you collect enough of that data over time, and you can synthesize it into predictive analytics and predictive modeling where they should spend the money. It's a real value to the client.
And it's delivered in a way that then can be delivered, as you say, to maybe the non-technical folks, but are still decision makers and stakeholders at the utility to understand visually yellow pins and red pins and green pins, and this is the transmission line on a map. It's it facilitates a discussion about the right things.
That's right.
And it allows the right actions to become self-evident.
That's right. Yeah, you don't want to spend a bunch of time on the 90% of your infrastructure that's in great shape. You want to spend all your time and focus and attention on the 5 or 10% of your system that has problems.
And the risk management and asset management folks appreciate that targeted approach.
Absolutely. So as I think, Ken, about all of your experience and all these great problems you're sharing, one of the things we always like to chat about here on the Integrity Podcast is how integrity has impacted your career, either seeing folks do things that are just phenomenal and awesome and how they held the line maybe in a really tough situation, or the opposite, where somebody cut a corner and led to some sort of really negative result. Maybe walk me through how integrity being everything in our business and in our industry, how that's been meaningful in your career.
Sure. Thanks for the question. Probably I think the best example was when I was with a large manufacturer and we had decided we were going to have some of our overseas plants produce and help us meet some peak demand at our company. And these plants happen to be in China. And that plan had been exercised before very unsuccessfully and caused a lot of problems and created a lot of trust issues to whether or not we could count on these multiple China plants to source, to manufacture and deliver product that met the North American utility customers' expectation and specification and codes. And so I got asked to get involved in overseeing a program that would reinstate our China plants to be used for customers that needed that material and there was no other place for them to go. We wanted to provide that as a solution. But we wanted to do it right this time. And so I had the opportunity. It started with going over and preparing for a re-audit by one of the major customers that really was the one that got bit by the failure from the first attempt to source from this. And we scrambled to put together the plants into a shape that they could withstand a U.S. utility audit. And I was worried that we may get past the audit and approved, but that we wouldn't maintain what they saw the day they were there for the audit.
And I'd like to point out audits, for folks that maybe don't know or haven't been through one, I mean, they're a snapshot in time, right? And it's usually the manufacturers putting their best people and their best foot forward. We see we score our audits from 0 to 100, like in grade school, and how often we're ranking people in a 60 or 70, very poor or lower. I mean, we've had folks rank in the 20s. Very poor grade, and that's the best the manufacturer has, right? I mean, that's usually the best people. They know you're coming, and so when you see a score and a failing grade and a prepared audit, usually means as you go down the manufacturing path, usually things dip from there. They actually get worse.
Yeah. So what I felt was important in setting up a sustainable program. One is they would see our product flow continuously. There wouldn't be gaps and they would revert back to maybe a different country standard. They would maintain as a minimum the U.S. standard. And the people there cared. They just wanted to know. They needed to know not only what, but why. And so we took a lot of time giving them visibility of the projects that we had targeted for their backlog, so there was confidence they could trust us in that. But we explained why the quality requirements were imperative. We were going to be held to a higher standard than the domestic plants manufacturing for the same project. And that investment and that regular communication, bringing back to them the results of their product that they manufactured laying horizontally on their welding stands, now vertically in service in a project that they built, was something that gave them that feedback and that ownership, closed the loop. And through that trust, there was, we could count. They could count on the work coming, and we could count on the work that they performed, even on the off shifts. That's always the thing. Integrity is really who you are when no one's looking. And that's third shift. That's third shift. And so those folks need to be seen. They need to know that they are seen in a good way. They want to be noticed. And that's hard to do around the clock when you're running an operation against a schedule. And it was a good success story of changing the culture for that program and being able to provide a solution to the U.S. utility because they needed to hit an energized date.
Absolutely. Yeah, and you see there, I mean, I think the synthesis of all of that is the right communication and setting the right expectations for folks so they know what standard they're supposed to perform to. That's probably a good segue, Ken. You think about the standards and the codes and the specs. You have sat on and sit on several committees related to the design or manufacturing of a lot of these materials. Maybe walk me through how that is for you, fulfilling to give back in that way, to volunteer on those committees, what you learn in those committees. Give me a little bit of commentary around that.
I highly recommend becoming involved in a committee, whether it be through the IEEE or the ASC organizations. As a young engineer, it's tough to get on those. It's tough to get a company to back you, to support you, to attend those meetings. But these days, it's a little easier with virtual participation in meetings. But when I first was asked to become a part of the steel pole standard, when I was first asked to become part of ASCE 48, which is the design standard for steel tubular poles. I participated as a member, and I felt like it was I was in a room with the gods of the utility infrastructure that I knew as a young engineer, and somehow I had that invitation to come and participate. And that's what I would encourage any young engineer or technician, whether it be to get a credential as an ASNT technician using ultrasonics or the mag particle or dye penetrant or other non-destructive testing methods, to achieve the highest level possible and to share what they learn, and or to become a certified welding inspector, or to be qualified as a welder in all sorts of the most complicated positions. But in those conversations, it may not actually be what makes it into the manual of practice or what makes it into the published standard. It's the most important thing are the things that are talked about, because a lot of what's talked about actually doesn't make it into the standard because it's a minimum guideline. And so, and the second thing I would say that comes as a benefit are the relationships, whether it be a quote unquote competitor or a customer or an academic or a regulatory person. These relationships, it takes time to do the committee work, and you see these people over the course of multiple years, and you have an opportunity to grow and learn and network with them in the future.
Absolutely. No, that's some good feedback. And really, finally, in closing, Ken, just as you look back over your decades career and decades long career, and you think about what you would tell a young version of yourself or a young engineer just coming out of school, what would you tell that individual today?
That's a great question. It's a challenging question. I think I would say what I used to address my manufacturing site with, which is great. You want to have a great career. You want to have a great employer and great experience in what you do. And so I kind of, came up with grow. G for grow, just to be in a situation where you're always learning and growing. And that takes a humble approach to every day, because you can learn and grow from any interaction with any person in the organization. And secondly, to respect. Give respect, extend respect, lead with respect, and then you'll find that reciprocates back to you. Respect the work, the importance of the work. And then to E is one of my favorite. I mentioned one of my mentors when I first started in working for the utility. Enjoy your work. I find it tremendously important that every day I've found something to think about, or some element of the day just to enjoy the type of work enjoy the people that I work with. And that's just contagious, and it's very important. And have A for achieve, because we're all measured, and we're all expected to deliver results. And achievement's a great thing. Achievement's an important thing, and it should be measured, and we shouldn't shy away from that. We should have those goals and feel the gratification of achieving them. And then T is teamwork. You're not doing this alone. And teamwork is important, and it takes setting yourself aside. It's not taking credit, and it is just making your peers successful. Make yourself replaceable. Instill what you know into everybody that's willing to learn about it. You don't want to have your fist around some knowledge because you think you're expendable. What you'll find is other people can rise up and help make you successful. And as you give that knowledge, you're available for maybe another assignment.
Absolutely. I think that's important information. I would say it's great information, Ken. But no, I think that's fantastic advice to give someone that's just entering their career. And look, really appreciate the time and really appreciate the effort and the work that you put into our business and sharing some insights today on your view of the utility industry. So thank you for your time today.
You're very welcome. Thanks, Zachary.
Thanks, Ken.